Hello. Yes, we welcome you back to PSSB, Physical Sciences. Silver bullet with me, Richard here. Yes, we are looking at this case. It comes from electrochemistry. It says that the setup below was used by Derek to electroplate his steel watch with nickel. So this is the setup. Yeah, then the question comes. It says that identify day, or you're supposed to write watch or P, the cathode. So which one is the cathode between P and the watch? Okay. How do we deal with this? This is what you have to know, that our electrolyte here is nickel nitrate. And so we are having nickel ions here. And they are nickel 3, basing on what we have here. This 3 implies that the combining power of valence of nickel is 3. Okay, and nitrate ions. So what is the intention of this setup? Is to electroplate watch with nickel. So this implies that nickel ions are migrating towards the watch. So if they are migrating towards the watch, it means that the watch is negative because positive ions are moving there. So what do we call a negative electrode? A negative electrode is cathode. So what are we going to conclude here? That it is the watch which is the cathode. Yeah, so that is it. So if the watch is the cathode, because cations are moving there, it implies that P is the anode. Yeah, then we come to this question. It says that state the nature of electrode P. Okay, there are 3 basic principles to consider in electroplating. 1, the electrolyte must be the salt of what you want to electroplate. So in this case, we want to electroplate our watch with nickel. So electrolyte must be the nickel salt. That's 1. 2, the article you want to electroplate, in this case the watch, must be the cathode. 3, the anode must be the metal you want to electroplate here. So if our intention is to electroplate the watch with nickel, this P must be nickel. Those are the 3 basic principles to consider every time the case of electroplating comes up. So in other words, P is nickel. It's a nickel metal slab. Yeah, then we come to this question. It says that write half reaction at the watch. So this is the watch. And you must remember that we have already identified our watch as the cathode. Okay? And what type of reaction occurs at cathode? It is reduction. So how do you go about this? So if it's reduction, what can we say? A reduction in terms of ion changes is the change from positive ions to solid. So which ions are we dealing with here? They are nickel ions. So which is going to be nickel ions are being converted to nickel solid. And how many electrons are involved here? There are 3, basing on the charge we have here. And that's what we write here. Okay. Yeah, then we come to P. Yeah, well, we already identified P as the anode. Okay. Implying that in terms of ion change, if it's the anode, what happens at P is oxidation. And what is oxidation in terms of ions? Is the change from solid to positive ions. So what are we going to have here? We are going to have nickel solid changing to nickel ions. Like we said before, the charge on the ions tells us the number of electrons involved and how many. There are 3. So we put them there. Yeah, then we come to this question. It says that write observable changes at watch. Okay. Yes, what are the changes we observe at the watch? This is what you have to know, that our watch is the cathode. And to answer this question, we need to know the reaction taking place at the cathode. And we observed that it was reduction, which is going to be nickel 3 ions plus 3 electrons, giving us nickel solid. Now, this reaction gives us the information as to what we observe. Every time you have nickel as a solid on the product side, it implies that the mass of the watch or the size of the watch increase. So what are you going to say? The mass of the watch increases. Yeah, then we come to this one. Observable changes at P. Okay. So what do you observe at the electrode P? This one we can obtain it from the reaction which takes place at P. We need to know that P is the anode. And what type of reaction occurs at anode? Oxidation. So in terms of ion changes, oxidation is the change from solid to ions or to positive ions. So what are we going to have here? We are going to have nickel solid being oxidized to nickel 3 ions. Now we know 3 electrons are involved, which we put here. Yeah. So this tells us what we observe. The moment you have solid, which is the reactant, breaking down into ions, that implies that there is a decrease in mass or decrease in size. So what are you going to say? That the mass or size of P decreases. Yeah, then we come to this question. It says that state what happens to the concentration of nickel nitrate solution and explain your answer. Okay, what happens here to the concentration of our electrolyte? The answer is it remains unchanged. And what is the reason for that? Okay, the reason is that the rate of oxidation at the anode, which is P, is equal to the rate of reduction at the cathode, which is the watch. So in other words, it's like the concentration is not participating, because as ions are coming out of the anode, they are being taken up by the watch at the same rate. So the concentration technically remains unchanged. Why? Because the rate of oxidation is equal to the rate of reduction. Yeah, then we come to this question. It says that give a reason why DC source is used. Okay, you have to take note that our source of energy is a DC. What does DC means? DC means direct current. It means that the current flowing in this circuit, it is in one direction. And actually the answer lies there. What does that mean? It means that our charges are going to be moving in one direction. So what's the reason? To ensure that the charges move in one direction. Yeah, with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences. Silver Bullet with me, Richard here. Yes, we urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. Stick with us. You won't regret. See you next time. Bye-bye.